Hi everyone, we have the group number 4. It is a project that revolution in the product time of the bonnet suit, the line at IPAC. It is our partners. And the IPAC is a metallurgical company specializing in profiles, covers, and galvanized steel sheets. 6. The reduction cycle time G. Next, please. While ensuring the product quality, the project general objectives involve the addressing variable x1, 2, 3, 4, and 5. This encapsulates the problem definition within the Dmaic methodology for process improvement. Next, and again, recalling the implemented improvement from the previous day, we have the summary of the 5F implementation in the raw material warehouse. You can pause the video to review it in detail. Additionally, we have the 5S improvement for the production and SMET for blade calibration. Next, please. This is a SMET improvement. And this is our implementation plan and Gantt chart. Next, was proposed for better tracking. Therefore, if we apply the 5S improvement in the warehouse, we reduce the variable 1, the query search, and consequently the variable G is reduced.
We have the current situation where JPROM are 57.12 minutes, and here we can see that we apply the earning and test student to determine of number of replicates necessary. In conclusion, we got 50 replicates that are enough to the process. Well, this is applied because this methodology seeks to improve the efficiency and quality of work, and this peak of the resource time is bigger than expected. We will start with variable x1, co-exchange time, and here we got the G product cycle time of the improvement of FIS in the warehouse, the improvement of FIS in the product line, the improved SMET applications, and the sum of all improvements in the process.
After making 50 replications, applying each of the improvements, compare each of the results with the company's current results using the Bonferroni method. It should be noted that the 4 scenarios have been established consist of the 3 solutions mentioned above and one in which all the solutions are applied at the same time. As a result, scenario 4 makes the biggest difference with respect to the current cycle time. Next, please. We can observe the average cycle time obtained by applying each one of the improvements, and that by applying all the improvements at the same time, we obtain a time of 1,703.60 seconds compared to the current one, which is 3,427 seconds. Next. In addition, by implement this solution, we also obtain improvements on the critical variable. Time next need to start production with an average time of 491 seconds, unlike weeks with the next, please, critical variable average time required to calibrate the circular blades. Obtain a new average time of 250 seconds. Next, it should be noted that the solution to be implemented also indirectly improves of the area of the CTQ3.
According to the analysis and comparison of the stability graph of the current case with the improved one, it can be observed that in the current case, the process is not stable. Because the graph in the process, there are 3 points that outside the limits of the control chart, that is the data that has variation. On the other hand, in the improved process, all points are within the upper and lower control limits and are not affected by special causes of variation. Therefore, the process is stable over time. Next, now with respect to capacity analysis, first it was verified that the data is normal to continue with the capacity analysis. Next, as it can be seen that improved case has had a great improvement. Since PPQ of 1.03 and CPQ of 1 are obtained, there are indications of the process that although close to meeting specifications could benefit from greater consistency and less variability to ensure stronger compliance with the specification of the clients.
With respect to the triple bottom line metrics, after implementing the improvements, we obtain better results and we will produce more that leads to have more income and decrease of several expenses. For example, in the environment aspect, we achieve waste reduction of 10 tons per month. In financial aspect, the energy cost was reduced to $10,000 per month. And in the social, we achieve a staff satisfaction of 3.5 average. Next, please. To implement all the proposal and approximate investment of $36,800 is foreseen. Signed, it incurs for several activities such as personal training, signage materials, among others. It is worth mentioning that a discussion was held with the production manager to improve the organization of the raw material warehouse. In an agreement was reached to organize the warehouse on weekends for 6 weeks. These activities are included in the economic analysis. Next, please. The following is the root causes control plan for each solution proposed, which detail how the control of complaints and optimal execution of the solutions will be carried out, in addition to the people in charge of the areas. It should be noted that this control will be carried out monthly. Next, the following is a flowchart showing how the audit will be carried out as a part of the control plan, which will be carried out for each of the proposal, which are redistribution, the warehouse, next, 5S in the Bonac 2 production line, and SMED on circle blind.
A3 analysis that details in a structured way the identification of the root cause and the action plan, as well as in the implementation of the improvement and results. At the bottom, it can be seen that in improved case, it was possible to obtain a time reduction from 3,000 to 1,700 viewers seconds. Okay, the visual control will serve to project it into the production area to evaluate its monitoring and performance with respect to production time and quality.
Well, as conclusion, we can say that we achieved the reduction of cycle time of the line production with good accuracy with the process. And as recommendation, one important recommendation is that we can put the A3 paper near to the boss office or the leaders of the process in order that they see how is going the project. And here we have the evidence. Thank you.